this is Kasturi Day. Now I'll start the discussion, or rather continue the discussion of the hydrogen chapter question answer series according to ICSE syllabus class 8. Okay, so I'll start with the description. Describe your observations when a mixture of hydrogen and air is exposed to candle flame. Okay, so when a mixture of this hydrogen and air is exposed to candle flame, it burns with a pop sound as air contains oxygen. As air contains oxygen and when it is exposed to candle flame, hydrogen burns in air to produce a pop sound. Then next is, what do you observe when hydrogen burns in air? Hydrogen burns in air with a very pale blue flame. Okay. And it is seen to produce water. Okay, so there is a pale blue flame and it produces some water. Now state your observations when equal volumes of hydrogen and chlorine are exposed to diffuse sunlight and direct sunlight, both the cases. So first is diffuse sunlight. We'll come to equal volumes of hydrogen and chlorine are exposed to diffuse sunlight. Then there's a greenish yellow color of the gases, which is termed the greenish yellow color of the gases that turn to formation of hydrogen chloride gas. Okay, so the chlorine and hydrogen, when they combine in diffused sunlight, the greenish yellow color of the gas change into colorless gas, and this is due to the which indicates the formation of hydrogen chloride gas. Okay, and when it is exposed to direct sunlight, then what happens? A blind flash takes place. Okay, a great, a bright flash type takes place, which you can say a blinding flash, which with an explosive sound, which formation gas with the formation of HCl gas. Okay, so there will be, when it is exposed to direct sunlight, a blinding flash takes place with an explosive sound with the formation of hydrogen chloride gas. Now next we come to briefly describe your observation when H2 gas is passed over heated copper oxide. When H2 gas, that is hydrogen gas, is passed over heated copper oxide, the black copper oxide, the color of the copper oxide is black. So the black copper oxide turns into red due to the formation of copper with the collection of the colorless liquid, which is water, on the far end of the test tube. So when we are taking a test tube in which there is a black copper oxide, and when we pass hydrogen through over that, we will see that black copper oxide turning into red, and on the further end of the test tube there will be some liquid formed. Okay, if we test that liquid with anhydrous copper sulfate, we will see that the white anhydrous copper sulfate will turn into blue. So this indicates that the liquid which is formed at the further end, that is water. Now state 4 uses of hydrogen gas. First is a flame of hydrogen gas with oxygen of temperature 2800 degrees centigrade, that is oxy-hydrogen flame, you call it. So that is hydrogen with oxygen when combined at 2800 degrees centigrade, producing a flame which is known as oxy-hydrogen flame, that is used for cutting and welding purposes. Okay, of metals. Then equal volumes of hydrogen and helium gas are filled in weather forecasting balloons, and they are sent up in the atmosphere along with meteorological instruments to record temperature, wind speed, air pressure, etc. That is, they are used for weather forecasting. Okay. Then H2 gas is extremely used in the extensively they are used in the manufacture of ammonia gas and HCl gas, which are again utilized for further other industrial purposes. Okay, ammonia and formation of ammonia and HCl gas. Then as H2 is a good reducing agent, it is used for extraction of metals like tungsten, copper, lead and tin from their metal oxides. From their metal oxides, these can be, the metals can be extracted, as hydrogen gas is a good reducing agent. Now, describe your observations when a mixture of hydrogen and air is exposed to candle flame. Okay, I think this has been repeated once again. Okay. Now, for this, just a second. Okay, next question is, hydrogen is used as a good reducing agent. What do you understand by the above statement? Okay, explain with the help of copper oxide as an example. Okay, now it means that hydrogen can easily remove oxygen from the metal compounds having oxygen and reduce them to metal. Okay, when H2S is gas is passed over hot copper oxide, this I told you in this in the previous reaction experiment. Okay, so this is the representation of this metal, see, of the reaction only. So see, this is the test tube. It has been taken where the metal oxide is there, hydrogen gases is passing through. Then what will happen, this metal oxide, the black copper oxide, will change into reddish copper, and at the further end there will be the steam will be liberated, which will cool down to form a liquid, which when treated with, if we test it with copper sulfate, anhydrous copper sulfate, it will change into blue color, and some of the hydrogen gas will come out, will produce a flame. Okay, then name a process by which hydrogen gas is manufactured, give equations for the reaction, and how is a hydrogen separated from carbon dioxide and carbon monoxide. The process by which hydrogen gas is manufactured is Bosch process. Okay, and the equation is carbon, that is hot coke, when combined with steam in the presence of 1000 degrees centigrade, it will change to form water gas and heat is produced. Okay, now from this water gas, this hydrogen is separated. Okay, so what will be that? So the process is like this way, that water gas is first mixed with excess of steam. The water gas which is formed, that is carbon monoxide and hydrogen combined together, this is passed over excess of steam in presence of ferrous oxide, okay, Fe2O3, okay, I mean it is ferric oxide, rather it is ferric oxide Fe2O3, that in presence of that acting as a catalyst, okay, ferric oxide acting as a catalyst and chromium oxide as promoter, and what do we see? We see that it forms carbon dioxide and hydrogen is liberated with a lot of heat. Now so the products contain three things, that is, one is carbon dioxide, another is hydrogen, and some unreacted carbon monoxide. Okay, to separate this hydrogen from this carbon dioxide and carbon monoxide, the whole mixture is first passed through water under pressure. Okay, the carbon dioxide, which when it is passed under pressure, it is through water under pressure, the carbon dioxide get dissolved in the water, leaving behind hydrogen and unreacted carbon monoxide. Now when these two, that is hydrogen and unreacted carbon monoxide, is passed through ammoniacal cuprous chloride, then carbon monoxide get dissolved in it, leaving behind hydrogen gas, and this is how the hydrogen gas is separated from these two gases. Now we come to define the catalytic hydrogenation of oxidation and reduction, and the redox reaction. So first is we come to catalytic hydrogenation. What is catalytic hydrogenation? It is a process by which hydrogen gas is passed through vegetable oils. We know there are certain vegetable oils through which, when hydrogen gas is passed through in the presence of catalyst, that is nickel, platinum or palladium as a catalyst, it converts into vanaspati ghee. Okay, that is known as catalytic hydrogenation. Next we come to oxidation. Oxidation, it's a chemical process which involves addition of oxygen and removal of hydrogen from a substance, that is, or from a compound. Then it is called oxidation. And reduction is the opposite of oxidation, where it's a chemical process which involves removal of oxygen or an addition of hydrogen to a substance. Now, redox reaction, it is the reaction in which reduction and oxidation both take place simultaneously. One substance is reduced and the other gets oxidized. Okay. So, this is the end of this hydrogen chapter question answer series. Okay. So, please go through this. If you have any doubt, please do let me know. Please do write in the comment box. And if you are liking the videos, press the like button, share with your friends, and go through the text videos to understand this chapter much better. Okay, and do subscribe to get the notification of my next video. Thank you for watching and have a good day.